Okay, so I want to find the first 4 terms. I plug 1 in because I want to find the first term of this sequence. 2 times 1 is 2. 1 plus 4 is 5. I want to find the second term. 2 times 2 is what?
4.
2 plus 4 is, can I reduce that to 2/3? I plug 3 in. I plug 3 in because I'm finding the third term. 2 times 3 is 6. 3 plus 4 is 7. Can't reduce it. 2 times 4 is 8. 4 plus 4 is what?
8.
And that reduces to 1. That's how I found my first 4 terms of the sequence. Let's go back to this a minute. An infinite sequence is a function whose domain is a set of positive integers. Why is an infinite sequence, why is the domain only positive integers? Can you have a negative 1 term in a sequence? No, you can only start with first term, second term, third term. You can't have a 0 term, can you? That is why that domain is only positive integers. Does that make sense? Okay. Are we all good on that?
Do you have any tissues, Mr. Rushford?
It's in the Student Resource Center.
Thank you.
Moving on. The first learning target today is I can evaluate a factorial expression. Factorial expression. You see that now we're going to learn what the exclamation point means in math, okay? That is a symbol that's called factorial notation. It's used in probability and stats. Is it a must right now or is it just dripping?
What?
Like if it was just dripping, like you would just hold it because it's very important right now. Yes. Nice. 5 factorial. The definition of 5 factorial means this, guys. You start with the number they give you and you multiply all the way down till you get to 1. That's what the exclamation point means. So if you want to find what 5 factorial is, you're going to say 5 times 4 times 3 times 2 times 1. And do that in your calculator now. That is your answer to 5 factorial. Nine factorial. 9. We're just living on your time, Matthew.
Thank you.
362,000.
9 factorial will be what? 9 times 8 times 7 times 6 times 5 times 4 times 3 times 1 times 2 times 1, which is what, Shay?
362,880.
Say that again.
362,880.
Does everybody agree with that? That is the factorial value of 9 factorial. Now you want me to show you what the symbol's at on the calculator? Alright, you're going to hit the 9. Go to math. In the math category, does everybody see this? Do you see PRB? That stands for probability. That's considered probability. Do you see number 4 exclamation point? There's your answer. It's under probability. You don't understand how I got there? Hit 9 math, scroll over 4, enter. Alright, I'm going to ask you something here. If I have 1 factorial, the definition of factorial is when you start from there and you go down to 1. 1 has to be your last number. What's 1 factorial equal to? 1. What is 0 factorial equal to? Definition of factorial means you start with that number, but you have to end with 1. Well, 0 factorial is also 1. And the mathematicians say this because the definition of factorial, you start with that number, go down to 1. Well, if you start with 0, you can't go to 1. So So the only value it can be is 1. So 1 factorial and 0 factorial is equal to 1. Okay? Alright, let's look at number 6. This gets more complicated here. Not hard, though. On number 6, I have 10 factorial over 2 factorial times 8 factorial. Okay. Now watch this. 10 factorial, I'll start. 10 times 9 times 8. Now, why do you think I stopped there for a minute?
Because you're about to do 8 factorial and all those would cancel out.
Yes, because after 8 you got 8 times 7 times 6 times 5 times 4 times... Couldn't I cancel that 8 factorial out with that 8 factorial? Yes. And I'm left with 10 times 9, which is 90. What's 2 times 1? And your answer is 45. That's the value of that expression. Huh? You could. Let's see. But I need to, you have to show work. See if you get the same thing. I want to see work on these. Okay. You can check it that way. But I will probably put 2 factorial and 8 factorial in parentheses. Okay, let's go to number 8. I'm going to come back to 7 and 9. Those are variables in a minute. Okay, on number 8, I have 14 factorial in the numerator, 11 factorial in the denominator. So I will start off with, okay, you tell me when to stop. I'll say 14 times 13 times 12 times 11. Stop, because I will cancel out those 11s, okay? So here we go. 14 times 13 times 12 times 11 factorial over 2 factorial times 11 factorial. Those cancel out. So I would, in fact, take my calculator and say 14 times 13 times 12. And what do you get? 2,184. And what's 2 factorial? 2 times 1 is? And that divides by to give you what? 1,000 what?
92.
Very good, that's your answer. So when I say factorial, I mean this expression with an exclamation point. Okay. Remember, a factorial, you start with that number, you go all the way down to, you're subtracting what off of each side? 1, aren't you? So let's think about this variable right here. I got n plus 1 factorial. So I'll start with n plus 1 factorial. What will be the next thing? I just took what off of it? Okay, think of this. If I start with 9 factorial, I would 9 times what? 8. How did I get from 9 to 8? I subtracted what off? 1. Okay. So right here, I'm at n plus 1. I'm going to subtract what off of it? 1. I'm at what? N. Well, now don't the n and n factorial cancel out? That's where I would stop at, okay? So I would write this, guys. N plus 1 times n factorial. And I stop right there because these cancel out and your answer is n plus 1. On number 9, I have n factorial. This is some variable. But if I was going from n factorial, what would be my next one? N minus 1. Could I stop there? Could I cancel out that in the denominator now? Because definition of factorial, I took 1 off. It's some number. I don't know what it is. But to reference, I'm going n. My next term will be n minus what? Well, that's what I want on bottom, isn't it? So could I cancel out so my answer is equal to what? N. Does that make sense? Let's watch this. So you have n times n minus 1 factorial. Because the definition of factorial, you're subtracting 1. That goes away and your answer is n. Does that make sense? That's as hard as it gets. You got to think about the definition of factorial. You're taking 1 off of it. I didn't say this to college. I didn't want you to go. We don't want you to go to college and not know what that symbol means. Some PreCal teachers do not get to this. You're going to be amazed when you go to college and you're sitting in a class of students that's in the same class as you, and they do not know what something means. You're going to go, oh my word, we covered that in high school. They're going to say, we never ever seen anything like that. It's amazing when you go. And we don't want you to be the ones to say, I've never seen that before. And we're going to do a lot more problems with this in our math workshop. Okay. Are there any questions on how to determine the first 4 terms of the sequence when given the rule? That's the rule right there. Are we good on that? I need a hand signal. Hand signal, y'all. Are we good on how to evaluate factorial notation? Hand signal. Okay. The last thing we're going to cover today is summation notation. Summation notation. This is something else that... Huh? Yes, that's the Greek letter sigma. Sigma notation. Okay, can everybody see the board? Is there a glare or anything that we need to fix? Okay, so I can use summation notation. This is called summation notation. But this is the Greek letter sigma. Sigma. And when you see this, you got to think, okay, it's called summation notation because it deals with sums of numbers, okay? A lot of addition goes on in these problems. It wants to know the sum. Now, this is how you read it. It wants to know the sum of all the expressions. You see there's a little number right here, n equals 1? Your range is from 1 to 6. They want you to plug in every number from 1 to 6 and get the sum of those expressions. Okay, so what I do is I start with the largest and go down. Watch this. Ready? 6 squared plus 1 plus 5 squared plus 1 plus 4 squared plus 1 plus 3 squared plus 1 plus 2 squared plus 1 plus 1 squared plus 1. And you can do some of this in head. What's 6 squared? Plus 1 is 37. 5 squared is 25 plus 1 is 26. 4 squared is 16 plus 1 is 17. 3 squared plus 1, that's 10. 2 squared plus 1 is 5. 1, that's plus 2, and then add those numbers together. Someone do that for me, please. 97 will be your answer. So that is summation notation. It means you're going to add. So that tells you what number to start with and go to. I went from 1 to 6. On this one, we're only going from 4 to 7. That means I plug 4, 5, 6, and 7 in. Here, I plug in 3, 4, and 5. You see that? Here, I plug in 1, 2, 3, 4. Here, 3, 4, 5, 6, 7, 8. Do you see how the range works there? Let's go this one for next. Okay? We got sigma notation. We want to go from x equals 3 to 5. That means we're plugging in 1, 2, 3 numbers. But do I have anywhere to plug that number in? So how many times I'm going to write 3 down? 3 times. 3 plus 3 plus 3. You see what I'm saying? You still have to have an expression for each of them, but there was no place to plug it in. So for x equals 4, x equals 3, there was nowhere to plug it in, but I'm still write that 3 down. Plus, x equals 4, there's nowhere, so I'm going to put 3 down. For 5, so that gives me 9 as my answer. But you still got to have that number down for each time that we were supposed to plug it in. Does that make sense? Okay. Let's look at 14. I want to go from what number? 3 to what? 3 to 8. You see, Mr. Fisher, if I went from 8 to 3, it doesn't matter. You're going to get the same thing in the end, okay? Okay. So I'm plugging 8. Here we go. So 2 times 8 squared plus 2 times 7 squared plus 2 times 6 squared plus 2 times 5 squared plus 2 times 4 squared plus 2 times 3 squared. You don't have to show me every little step, but you do need to show me at least the first step if you plug it in. Now I know that 8 squared is what? So you can do that. You can put 128. 49 times 2 is 98. 36 times 2 is 72. 50, 32, 18. And then add those up. But they're called summation because you're adding these expressions together. So your answer is 398. That's the summation of that problem. Have you ever seen this symbol before? Have you? You seen this in math class before? All right, let's go to number 11, and that's going to be our last one for the day, and we will, I don't know, we might need to do number, I'm going to write number 11 down here. We might need to go ahead and do 13. Number 11. Number 11, we're going from what two numbers? 4 to what? 7. So I put 4, 5, 6, 7. So here we go. Negative 2 to the 7th minus 5 plus negative 2 to the 6th minus 5 plus negative 2 to the 5th minus 5. This one's kind of a more complicated one, so you might need to write a lot out here. Negative 2 to the 4th minus 5. Now, when you plug negative 2 into the 7th power, is that going to be a positive or negative number? Negative. That's going to give negative 128 minus 5, which is negative 133. You might need to put that in the calculator. Make sure you understand how I got negative 133. Negative 2 to the 6th. Will that be a positive value or negative value? Positive. That's 64 minus 5, which is 59. Negative 2 to the 5th will be a negative 32. Minus 5 is a negative 37. Negative 2 to the 4th is 16. 16 minus 5 is 11. Then I would add those. And I get negative 100 as my value of that summation. Yes, sir. It's got to be in parentheses. Always negative basis, or they're going to give you the wrong answer. When you put in negative 2 to the 6 or negative 2 to the 7, basis have to be in parentheses or something give you the wrong answer. It's not too bad, is it? As hard as the lesson gets done. Tomorrow we'll start looking at specific types of sequences. We start with arithmetic tomorrow and then geometric on Wednesday and Thursday, review them. All right, let's look at number 13. Make sure the fraction doesn't scare us. Okay, I got negative 1/2 raised to the 4th plus negative 1/2 raised to the 3rd plus negative 1/2 raised to the 2nd plus negative 1/2 raised to the 1st because I'm on from 1 to 4. Now, when I raise this 4 power, you got to raise the numerator and the denominator. So it'll be 1 over 16 plus negative 1 over 8 plus, that's a positive because I'm squaring it, plus a negative. You raise the numerator of that power and the denominator. Some of you might need to put that in the calculator and make sure you get the correct answer. Change it back to a fraction once you find it. I'm not going to give you the answer till everybody's had a chance to put that in the calculator. What did y'all get when you came up with that? I got negative 5/16. Retype it in your calculator if you did get that negative 5/16. Negative 5/16. If you did not come up with that, let me come help you. But if you have, here's your homework assignment. It's page 7, numbers 1 through 17 odd. Now, I made a mistake on number 13. There's an I in there. I didn't want you to get that. It should be n squared, not I squared, because I didn't want you to get that confused with imaginary numbers, okay? Page 7, 1 through 17 odd, and change number 13 to, instead of being 2i squared, it should be 2n squared. That's what number 13 should look like, okay? Okay. Are there any questions on learning targets?
What did you say you got?
On number 7,
No, on the
you should have gotten negative 5/16. Yes.
I won't be here tomorrow because I see my test.
Up to your grade right now.